Good morning, good afternoon, everyone. As usual, this meeting will be recorded. And so if you want us to edit something, please reach out and then we can remove any content before we share on YouTube. So the agenda for today is less structured than usual. I thought it would be helpful to have a discussion about organizing the data analysis. We already did a couple sessions on this, but now that the data is coming out, I feel like, I think this discussion will be helpful. So I didn't plan for any really strong structure. I just want to follow the questions and the opinion of the group. I do want to share an update on where we are with the data release paper before. So we continue to work on the method section. So using the Google Doc that is here, the method is getting fairly extensive. We set ourselves to do all of those sections here that describe the experiments. I think we made a great deal of progress on surgeries, ISI. We actually could share the ISI imaging. I just discovered that last week, so that will be useful in some cases. We had description of behavior training protocol done, a first pass. I made a first pass of the visual stimulus in the last few days, as well as stimulus parameter. NeuroPixels was described, as well as imaging. I think imaging might need another iteration. SLAP2, we are waiting on the first draft. Behavior tracking, I think there's a little bit of document, but probably not enough. This, we are waiting for the imaging team to provide this content. The processing pipeline, we have a first draft from Alessio. 2-photon, we need more details. And the SLAP2 pre-processing, I think, is also something that we need work. But we have, more than 2/3 of the content probably written for the methods. The team is trying to sort of finish the core of it this week, and it will be really helpful if starting next week you start to ask questions so that we make sure that it's well detailed for any analysis moving forward. But our goal is to finish the method section on our end in the next weeks or so, so that we can focus on the next step. And then last week we presented our first raw data. Carter and I are working very hard to get you the merge NWB. That's our goal this week. So to give you access to the NWBs with the stimulus and the neurophysiology co-align, so that it facilitates downstream analysis. So we already have some on Dandy, but it's still pending verification. But we're fairly close there. And so Carter will work on adding additional description of the data structure as we had last week, but just in writing, so that it's available to start the analysis. Any questions on that? Brief summary?
Hi, Jerome. I have one.
Yep.
Would it be possible to alert us, maybe on the forum, when new things go up so that we know when what becomes available?
Yep. We're planning to do that. I think this week we'll have more NWB fairly soon. Okay. So any other questions?
Just really quick. So I don't know if people saw it. I posted some preliminary analysis on the forum, so the code might be helpful to other people as well. And the one thing that maybe sticks out, so I was able to do, I don't know if you saw, I was able to do the receptive fields and the orientation tuning across all three techniques. So that should go for one session each. That should go pretty far towards that paper. But the number one issue I ran into is not knowing which neuropixels is where. And so I wonder if we can get that before the submission.
NeuroPixel. What do you mean there? Can you give me more details?
Well, because we don't have the clarity done, it's unclear. So
Oh,
ideally
I
we have
see.
V1, 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 but I don't know. I can kind of guess, but I don't exactly know where V1 is in the neurophys data.
That's right. I wonder if Severin wants to update on the group there. You there, Severin?
Yes.
Oh,
Sorry, one second. Yes, so
oh, echo.
yeah. Is it better?
Yeah,
No.
no, it works.
Okay. So we are working toward having the CCF alignment. We have a little problem right now with the imaging. So we're waiting for many brains to be imaged. But you have already the CCF for the pilots, I think. And that should represent basically what we did with the other mice. So it will come, but just be patient, please. Yeah.
Okay, so I have
I
a
mean,
follow-up question real quick. So if that might be taking longer, I wonder whether we can get the experimental notes that just say which probe targeted what part of the brain. Because, for example, if there's a probe that targeted V1 of several, then or VISP, then I know that at the top of the electrode that has to be V1. And so that would all we need. So we don't maybe need the whole CCF, just that info if you have those notes.
Yeah, so I can provide this for sure. Yes.
I mean, the alternative
I will
would
put
be to
it
just
maybe in the chat, not in the chat, in the GitHub repo.
or you in the session table, maybe is that possible?
I wonder, is it flagged in the session table, the data sets that Severin just mentioned that already have been registered in alignment? Because as long as we could just use that.
I think yes, it is. In the columns, there is a column for CCF data assets. Yeah, so it should be visible. If it's not, please ask us questions on the forum, and we can make sure it's visible.
So I look into that. So there's two sessions up, I think, right now, right? Two NeuroFest sessions. And I didn't see it in the NWB file. Is it in that Google Sheet file?
What do you mean? Didn't see the coordinates?
Yeah, maybe I gotta look into this again. So the question is basically, it seemed that it was easy to find out which areas were targeted, but which probe ID corresponds to which areas are targeted. That's basically what I'm looking for.
Okay. I mean, we can bolster the documentation if it's not clear.
Yeah, it's very easy to do that. Yeah.
Yeah, we need to do it anyway. That's an action item for us. Okay. So why don't we discuss the data validation a little bit more? And sort of, I think maybe what would be helpful is seeing the things that we can already start working, and whether they are subgroup that should form to address FUS. So just as a reminder, the goal of this section is to validate the quality of the data, so has to build confidence that downstream analysis can be done. And so we selected a number of figures. The first one is a figure that look at SNR across the units. so essentially amplitude of response and SNR, just to get a sense of the quality of all the units. So for NeuroPixel, it will be EFIS units. For 2-photon, it will be SOMAs. For SLAP2, for 2-photon mesoscope, for SLAP2, it will be a single spines. And we imagine a figure with 3 columns that show the quality of the units for each technique. So we probably have to sort of think about what are the things that make sense across all of them. The following figure is receptor field across modalities. We selected this one. And yes, Sarah?
Just a quick question to understand. So with response amplitude for electrophysiology, do you mean the amplitude of the action potential? Or do you mean some kind of reference frame of firing rates?
I think both could be interesting.
Okay,
right?
just to
So,
just to clarify what the metrics should be.
I think there, I mean, it's up to us to decide, but if you want to see the quality of the units, you probably want to have some estimate of the background noise and then the size of the spikes probably against that floor. So it's probably some kind of Z-score for
Sure.
all of the units. And then I think Kareem in the previous meeting suggested, for instance, we look at the stability of those across a session. And so we could do that for whole technique. I suspect that the firing rate is good to look at the health of the cell or things like that.
I think it would just be good to kind of make a specific list of what the metrics are that we mean, because, you know, response amplitude, as we see, could mean many different things for different people. And so just to make sure we're on the same page, basically.
Well, there are 4 people here that are listed. I wonder if could that be an action item to make this list among those 4?
Sure.
I mean, Sarah, would you want to lead that, or what do you think?
I mean, I don't mind, but I mean, Nicholas and Ido are happy to pitch in as well, right? Basically, I think the point is to find the common denominator, or at least to say what are the distinctive measures which are really important for the different modalities. That's another thing, right?
That's right. That's right. But I mean, you've touched the SLAP2 as well as the NeuroPixel, so so I think it would be helpful to have an anchoring.
Sure.
If you could work with the others and then sort of draft this list, that might help sort of get started. What do you think?
Yeah, that sounds good.
Any other people have thoughts on figure 4 and
yeah, I have two things real quick. One is, do we want to also show something from the spike sorting that you guys have done in the pre-processing to show some kind of statistics or something that comes out of that pipeline in terms of how many candidates you had and you identified the neurons that are then in the NWB?
Yep. Yeah, I mean, you have access to this already for both the mesoscope and the NeuroPixels. It's in the files that we shared last week. So I think this figure could already be started. Stefan?
2 thoughts. One, drift. The fact that we know that there is some true representational drift in itself, but every time when publishing and when talking about that, everybody really obsesses about the experimental drift. So measures to actually show that the elements for stability, I think, would be the most important to have here, including, for example, placements on the units, or if there are units which disappear for 5 minutes during the trial, or statistics of that sort to try to include, and the new unit appeared during that because the electrode moved a little bit, or what are going to be measures from that sort. 2, there is a continuum measure when trying to define what is theoretically a neuron, because you're going to have weaker and weaker signal as you get further and further away from the electrode. Do you want a unique measure which is going to be present and to say, hey, this is what we call spikes, those are not? Or do you want, for example, for other people to allow to say, hey, if you're not as strict, potentially spike candidates, which are potentially good, but they don't have a strict criteria to be present, to have a secondary list for them. To have a unique threshold for QC, or to have multiple and somebody can turn their knob on their own.
See. Sarah, you want to answer it?
Yes, I would argue that both levels need to exist, but I don't think you can say you have, a perfect classifier to define a threshold above the noise, because it might also depend on where the electrodes ends up being, basically. So I think the point is just to at least define the thresholds that have been used to classify units as good units based on the output of spike interface and then further refinement. But then essentially say if someone wants to try to play with that threshold, right, they can go back to the raw data or the output of kilosort and just change the threshold as they like, because it might really depend. The same thing is with refractory period violations, things like that, right? It's not an absolute science. It's just a matter of having some clear parameters set out.
But you plan to include those,
yeah.
you plan to include a figure like that, those things in some subpanels in this figure, right? To say here it is the criterias, which were some type of drawing where you present these are the QC criteria. By the way, if you want to relax them, here are going to be the measures. Here is the data. Here is the measure too, if you want, but then you're on your own if you want to relax them. That's the plan,
Yeah,
right?
I think so. And at least, I mean, we could reference some of the previous work that you guys have done, right? You have quite clear standards for the NeurPixel data sets that have been released up to now. So one could adopt these, or say for some reasons, for some brain areas, we had to change them, but it's not like it needs to be done from scratch.
Yeah, but I have to say that it was very difficult to go and to change the criteria. For example, we had to do it for some representational drift paper to actually increase some of the criteria, and it has been a pain. Right, so having somehow of a pipeline, having a way to be able for somebody to go in and change that might be, we haven't even actually been able to publish that because in the end it took so much time for the person who worked on it that we haven't even finalized it.
So very naively, how do you change them? Isn't that just parameter settings at the level of kilosort, basically? And then, choosing the output based on that?
Yeah, but as a user later on, getting to the kilosort data, getting to the original thing was impenetrable.
Okay.
It's not mathematically complicated, right? It goes there and it is a figure, right? But it was not, that was not the issue. The issue was not, hey, we should change that parameter. Yes, I know, I'm with you, and I was talking to the student, but the student was, okay, where's the data? How do you get that? What is the API? Because API, everything has been built around the data which was considered QC'd.
That's the distinction.
Yeah.
I think, Stefan, I think you're referring to accessing the data through the LN SDK. Is that correct?
Yeah, and not only that, but then running kilosort, where is it? What was the version? What was the what were the things which were right? So trying to rebuild and trying to rego. So if we want to do the right, so there needs to be a decision right now. Do we want to have our gold standard for QC? And we say, hey, only the things which are QC'd move forward, and we've got APIs and everything for that, which has been, I think, our standard in the past. And theoretically, you have access to the other, but practically, even for people internally, it's nearly impossible to try to rerun that type of data analysis.
Stefan, I think we are in a different situation for two reasons. One, the raw data, we already shared it. It's directly accessible to everyone on an S3 bucket, and that includes the processing assets that has the kilosort output. And then the next stage is we package these output into NWBs ourselves with Carter. And so we can actually play here on how the units are included and what metrics are included. And so, for instance, if Sarah and others decide on particular metrics are worth play with to sort of play with the inclusion criteria, we could do that later on, like regenerate the NWB, had an additional criteria that would facilitate this work. Sarah, sorry, I interrupt. You wanted.
No, I would just like to add, I think it's also, I mean, there are truly two levels, right? And so I would say one level is to meet the true electrophysiologist who knows that spike sorting is an art form and has to suffer through it, but in the end can defend their own, settings. And the other one is to leverage a data set that has been curated with the best interest at heart, but doesn't present the ultimate truth either. And so I think the point is to just be very clear about this and make sure that people don't really believe that this is the actual final truth of what's in that data set because that's been curated and presented as an NWB file, because that might be a misconception that some people might just develop over time. But I think we can make that very clear.
Alex?
Yeah, I think the deeper question is, should this paper that we're aiming for be about the NWB files or the raw data or both? So if we stick to the NWB files, which was in my mind, then we can point to the raw data, but so you can basically say, if you're interested in these questions, you can go to the raw data, but the paper sticks to the QC data. And because in my mind, that is maybe what most people would want to use and what is also easiest for us to analyze. Now, this question about is a spike has been around as long as there's been neurophysiology. And the solution was that in the 80s, when we started doing this in awake animals, to not call that in your paper a neuron, but a unit. This is why it's called single unit data and not single neuron data or multi-unit data. And in the figures, back then, people had more discipline. You don't talk about spike rate, but impulses. So you would say spikes per second, but impulses per second. And so the idea was that there's a didactic angle here to teach people that this may not be a neuron. And so, because in the end, you can use a tetrode, and you will always find that what you think is one neuron might be two, and so on. So people have shown it. You can go as high as an octatrode, and it dissolves even more. So there's no limit.
That makes a lot of sense. Yeah. Okay. It sounds like we could consolidate a list of those ideas and then given between the people that are listed here, start to sort of assign subtask for each one of these. Would you agree, Sarah? Or?
Yeah, I think it's a good idea. And maybe we just post it as a document on the forum so people can have a look, and if they feel something's missing or key, they just add to it and then we can discuss.
But again, these P's you can already start on most of it and I think that will be really helpful because everybody will get familiar on how the data is processed, and then we'll on our end had even more documentation on the current units criteria that are in the output of Kilosort, for instance.
But I think maybe one thing that Stefan said that would be useful to add or at least keep discussing is if someone is specifically interested in representational drift, would they have metrics that at least they could use to argue that's what they study and not just motion artifacts or other issues that may arise throughout an experiment.
Yeah.
Isn't this complicated by using Kilosort 4? So I mean, the new Kilosort is tracking. So there's representational drift, which is a change in the latent space, right? And then there's the actual physical drift of the electrode. And I suspect you're saying that if you work on that, you have to tell the two apart. But isn't Kilosort 4 keeping track of neurons that move between electrode contacts and then tell you that's the same neuron? I thought that's the case. So that complicates the matter.
I don't know if it complicates or but it in principle it could help.
Yeah, if one trusts the assignment to be correct, I think everything is great. But most of the time, you can go and trust it, but then your reviewers might not. So even in that case, even if you trust it, you'd need to go and follow up with proofs.
Yep. I think for me, this is a really important effort of documentations and validations, and there's no perfect answer. It's just a matter of maybe being transparent and what are the solution we chose. Okay.
I mean, it makes
Would it?
makes it easier to write the paper if we stick to the NWB files and do what you said, Jerome, and show some output from the spike sorting that explains how we got to where we are. Because there's a
Yeah.
related question. So right now we have spikes in LFP in the neurophysiology data. And so the related question is, should there be anything about the LFP in that paper? So right now we're only looking at spikes. And so if yes, then the next question might be, what about analog multi-unit, where instead of low pass filtering or band pass filtering between 0.1 and 100 hertz, you go to the kilohertz range and you just throw all neurons together as a population signal.
It's worth so the it's funny. So the NWB files will be stored on Dendy, and so there will be a permanent record of them. Dendy is storing its files on OpenAWS bucket, and the raw data is actually storing exactly in the same location through the same AWS program. And so I think it's likely that they will both live on this bucket as long. Uh, and so we could decide to document the access to the raw data um, in the paper, probably. I don't know if it will get a permanent DOI, but it will be available for a while.
So just to double check, so the NWB data, when you get a Dandy account, you don't even need a Dandy account, right? So you can access it freely from anywhere. So that's a benefit. Is that true for the raw data as well?
That's right.
But okay, but the pipeline that you used, that Stefan was talking about, that lives on CodeOcean, right? And so therefore it's non-public. There's a paywall.
It's not a paywall, but and we want to open it up. And well, first,
Okay.
all of the code of the pipeline is in public GitHub repository, so nothing is held up. And you can run this code anywhere. We're actually writing many papers to sort of deploy this pipelines outside of CodeOcean. It's not going to be restricted. There's a problem of compute because we can't open compute to the entire world and support funding for it. And so if people wants to do compute in the cloud, we have to find a way to sort of support it in a way that it's accessible to all. But currently we don't have a final solution for this, but there are people at the island that are working very hard to make this even more available.
I mean,
Yeah.
one thing that comes to mind is, so looking at CodeOcean a little bit, it seems that a lot of these are Docker files. So could you just maybe release the Docker, and then other people can, because if you just release the code, you exactly get the problem that Docker files and CodeOcean solves, which is that the dependencies might be different, and you can get it to run.
We could have an introduction to this. So the repository that contain the code that we run has a Docker definition in it. And the Docker, so you have the Docker definition, the Docker file that is in the repo. You can find it. And then the built Docker is on the ECR and AWS repository of Dockers that you can probably already pull. And so because the vision is you can actually pull the Docker that we built and rerun the pipeline on premise outside of the cloud already.
Great. I mean, doesn't that solve Stefan's request then? So basically, you have a Docker package where you can run the whole pipeline. you have the raw data somewhere, even if it doesn't have a DOI, as long as it's a hyperlink or URL, and then we can add that to the paper. But then the figures and everything is about the NWB.
That's right. That's right. Because I think if we have the figure from NWB, we can replicate them. People can replicate them. Yeah. Sorry, Stefan.
Sounds good to me. One quick thing to add for what is that figure would be, I think, would be interesting to have some LFP characterization beyond spikes.
Yes, but I'm just thinking we're starting to have multiple figures in mind. Sarah, maybe why don't you start laying out what will be useful?
Exactly, I can make a list, and we can add for LFP, right, basic metrics like power spectrum and stuff. It's just that it all depends on when exactly you generate that. Is it across, the whole recording, or it's kind of a bit arbitrary of what you get from it. Apart from that, some places might have more oscillatory power in something than another, but it doesn't really have much explanatory power at all.
I mean, we already did. Ali with Poisonné already did some analysis of LFP, and so I think it's probably something we could add already, either here or later. Yeah.
I was imagining something like an current density across layers to make sure that things align, that wherever you say layer 4 is, you do see something which is right, things which are going to be somewhat more common sense, not fantastic, oh, do you have a change in gamma or beta as you get, no. I was imagining much more raw things such that people would imagine, no, that actually looks good in terms of the depth profile.
But just to say, in none of the previously released data files, that was a step that was taken to define a layer. A lot of the previously released EasyFIS files have pure channel depth, and that's all you get, basically. And so there's not even a functional alignment present.
I wonder if it will be worth having a layer/brain area figure.
Yeah, we could do it for one session. So for each brain area, show a CSD as a function of time, maybe stimulus triggered. That would maybe help.
I think the layering is very important. Given all the questions that we have in the review.
But yeah, that will require both, right? The anatomical reconstruction plus the CSD, because the angle of the probe is not always the same. And so you can't use fixed steps.
But having done this groundwork will be helpful, right? Downstream.
I agree. Yeah.
So it may be like the last figure, the figure 8 or something.
Does the anatomy, the CCF, is that with laminar resolution? What's the spatial resolution that you get?
So what we do for the laminar resolution, what we do in the software, the IBL app, where we align the areas to the probe, we just delineate like the top of the cortex and the bottom of the cortex, and we have like the layers defined by the CCF that we don't touch. Like we just follow what the CCF tells us, because we have no way in this IBL app to just decide which layer is what. So we just trust the CCF in this way.
It's something you could further refine using LFP probably. Would you agree, Severin?
Yeah.
Yeah, if you have the CSDs, yeah. But as you mentioned, the angles are different, and there's no like straight angle basically.
So there was a presentation at SFN once where they both by computation modeling and experimentally looked at how much of an angle CSD works before it breaks down. And I remember it was something like 25 or 30%. So it's quite robust. So if you find a sink in a CSD, even if your electrode is angled, you would still know that that should be layer 4.
Okay, that sounds good.
Yeah, I think the
Well,
challenge is to calculate the depth of the layers, right? The absolute depth of the layers. To anchor it to like a boundary is fine in the CSD, but then in principle we would need like firing rate of layer 5 to know when does, you know, layer 5 follow and end, things like that. So it all becomes a bit fuzzy, honestly.
Yeah, so what we've done in the primate literature is you basically set this the bottom of the initial sink as the boundary between layer 4 and 5. And then the rest you keep in relative units to that because it's so difficult. Especially my understanding is in the mouse, even anatomically, it's very difficult to tell the layers apart. So and so basically to be agnostic about, I don't know exactly where the layer 2, 3 boundary is. Layer 6, for example, doesn't even have a clear boundary at the bottom, right? So you get just less and less neurons as you go into the white matter. It never really ends. There's interstitial neurons that keep going.
This is made more difficult in the prefrontal cortex, probably.
Yeah, that's true. Yeah, if you don't have
But we-
layer 4, it makes it very difficult. And yeah.
So an opinion regarding not putting too much work on this. I think that the tools which are present for the anatomy are pretty robust and pretty solid. Modifying them to include the physiology might not be very easy, but simply providing the two such that people can understand and can have some type of conflict resolution might be the type of thing which would be by far the easiest. To have Sev to have her standard pipeline to be able to just go through and create based on the anatomy, present the CCF, and people later on decide what to do with that information, and probably they're going to be well aligned. My expectation is that there are always going to be a few things here and there at the corner and everybody would need to be aware, especially later on when trying to make hypotheses, what to deal with that fuzz near the center.
Yeah, it's also the problem is that the CCF uses a standardized atlas, right? So you're not actually, if there are individual variations, you wouldn't catch them, right? Yeah.
Okay. Should we discuss the receptive field figure side a little bit, which is the next one? And Alex, you said you'd started to do work here, or?
Yeah, so if you look on the discussion, I can post a repo as well, but I condense it down to a Python notebook that you can just click on and it runs in Google Colab and spits out all the figures. And so the long story short is what I first did is for all 3 techniques, just pick one session because we have 45 NWB files for the 2 photon, 2 for the electrophysiology, and I think 12 for the SLAP. And the SLAP data is, some of it is pilot data, most of it is pilot data where it didn't run the full paradigm. So but I think all do the receptive field mapping and orientation you can also extract from all. And so what I did is the first just show the stimulus evoked response for some demo samples. So there would be demo somas or demo spines and demo electrocontacts or units. And so you see that you got a nice stimulus evoked response for all 3 techniques, and then use some of the best examples again to compute receptive fields. And so from where it stands, it looks like we got very nice receptive fields with the 2 photon and the neurophysiology. They're almost indistinguishable in terms of the quality, the size, and everything, the signal to noise. And then the SLAP2, they look also clearly like receptive fields, but they're a little bit more noisy and broad. That could be a bug, but so that's one session, and I have basically examples that you can look at. But the good news is it seems to work.
Great. I think Severin also had shared, yeah.
Can I ask you, where did you put that, Alex? I would like to have a look.
If you go on GitHub discussion,
Yeah.
for the GitHub reproduce discussion, I think it's at the top right now at the title, some analysis progress. And
Okay.
the figures are right there. The figures are right there. So if you scroll down, you can see the receptive fields. If you scroll further down, you can see orientation tuning and direction selectivity tuning. And then lastly, I also looked at some of the oddballs.
Okay, thank you.
Alex, do you think you could lead this effort with Lucas?
Yeah, happy to. The other thing I wanted to bring up, so I did a lot of that with Claude Code. It took me, even though I'm on the $100 per month plan, it still took me a week to get it, to understand all of this. So this is highly complex. And so I've caught a bunch of things that did wrong. So there may still be problems with the code. I have to audit the code. But I'm wondering if other people use Claude Code for that, whether we should share the skill files and the Claude MD files so that we can people don't have to do this whole effort of teaching Claude Code what this data set is.
Yeah. How do we organize this effort? I mean, should we have a separate repo for storing all of those files or use the current one? What's your opinion?
Yeah, that's an interesting question. I could just upload what I have so far on the discussion board, and then maybe for now, because these are small files, these are just small text files, right? So, but then maybe in the end, we want to maybe publish all of this more permanently. It might not make sense because as Claude evolves, these files might become useless or the limitations might change. But for now, it might be helpful to synchronize. So we do this in our lab. So we share the skill files. And so it helps to kind of synchronize the AI-based analysis that people do.
Yeah, I've been using Claude. I have pipelines with 20 steps now, so and skills. And so, yeah.
Yeah, the main limitation for me is the context window. So I don't know if that is, so this is definitely beyond what the context window of Claude can do at this point. And so very often, once it understands, yikes, I have to treat different files differently, and tries to keep all of that in memory. I had it even happen that it forgets which directory or repo we're working in because it's trying to condense the context window. But these are all things that should change in the future.
Stefan?
Isn't this something which should be in the methods of the paper?
Well,
yeah,
it's in the method, the
I
skills.
agree.
Yeah.
Yeah, right. The part which it
Maybe,
is
yeah.
the moment we are using some agents on a paper and we are trying to put everything to be able to go through and see how you're going to create that code. I have no idea. It's totally new to me how do you publish something which is going to be with a code which was AI generated? I have no idea I think we need to set some standards for that.
Yeah, good idea. Yeah.
But by the way, in my mind, this data release paper is very important to enable AI-driven, so I envision that people will point AI agent to the paper, load the context, and then drive them towards certain. So this way, there's the whole details of the experiment. So this paper is very important also in that sense.
Yeah, Jerome, except the real challenge for the AI is to understand details of the NWB files that wouldn't be in the paper. So, for example, if we incorporate the pilots lab 2 data that didn't run the full paradigm, or that sometimes the session was cut short, or so
Yeah.
it's those files. So maybe we could include that, right? So we could have a table in there to teach the AI that you cannot assume that all these files can be treated equally. And so we have like a file by file annotation of where the AI has to be careful.
Yeah, I mean, I was actually planning to do that. Sorry?
Yeah, I kind of had a different instinctive response to the AI problem. So I'm wondering, shouldn't you have kind of at least 2 separate teams that try to implement it individually so that you can kind of cross-validate whether, the differently generated codes actually get to the same biological message? Because I'm just concerned that everything goes into one pipeline and then who knows whether at some point something creeped in and no one noticed it. So it's almost like maybe having individuals playing around with different sections as a sanity check would always be valuable.
Thank you, Sarah, for keeping us grounded.
I'm just scared. I'm very scared. Let's say it like that.
I have also a question too about the use of these agents. So how much code are you using to generate? How deep are you getting to an analysis with a single Claude agent? I haven't used it before, so I don't really know much about it.
Yeah, so I was able to use the paradigm and all three techniques to get, for example, RF and Ori and Oddball. So it can go pretty deep. So, but and then also what I did for that, for what Sarah said, that in the end I condensed, it's a whole repo, and then I tell it, okay, now write a Python notebook that stands on its own, and that will be easier to audit. But I like the idea of having like an adversarial approach where we have two different AI teams work and make sure that it converges. That's a great idea.
Kareem, you had your hand raised? Or?
Yeah, I was going to echo what Sarah said. I think it's super important that there are two independent and parallel paths where one is, the sanity check and then the other one is the AI route. I would also suggest that with every file that has been analyzed using AI generated code, and if each experiments require its own sort of custom made or specialized code, we would basically associate that code with that specific file in the data supplementary material, in the paper supplementary material. I don't think there is a one size that fits all for all the experimental sessions, unless somebody came up with a unique piece of code that would be validated using the existing, manually generated code. That would be great, but I doubt with this much data there will be one size fits all kind of thing.
One thing that I could do in the next week or so is try to provide a place where we put each figure's code. Because and it could be a sandbox, but I just, as people do more and more analysis, we need to just post figure code on Git so that it's reproducible and people can check the provenance. Because if you use AI, we need to sort of be transparent about how the figure was generated. And so if the code is on the repo and you can run from the NWB the generation of the figure, I think there's less risk of hallucinations because everybody can check on everyone at work. So I could spend a little bit of time sort of structuring a little bit how we document the figures. But I want to go back to the receptor field. Alex, do you think you'll be able to work with Lucas and sort of set up a number of first version? Okay. And the rest of the group that is listed here? Okay, it's 9:51. Do we have time to discuss the next figure, the behavior tracking, or we have enough to work with in the next few weeks? Probably
I'm curious
that's
about
enough.
I'm curious about figure 7, Jerome. That should be about demons.
Demons?
Yeah, it says response to standard upper stimuli and demons.
Oh, who wrote that?
I'm kidding.
Demonstration.
Sorry.
Oh.
I was wondering also what that stands for, but it's not me or Nicholas, I believe, who did that.
I was a little concerned too. I was a little concerned, yeah.
All right. Just,
I can tell
like
you, once we get our hands dirty in this, demons will start to appear. I'm sure.
The AI demons. Well, at the Allen Institute, we call them gremlins. They come onto the rig overnight and just messed up our rigs. Okay. Should we have it feels like between these two figures we have plenty to do. Because I think just figure 4 and all of the related effort is a big, I think it's a big undertaking. just making sure we understand the processing, the units, the quality creations. I feel like that's a big value added to the paper in my mind. When should we? So next week, we have an SAC, an advisory board, and so I won't be able to probably to lead because there will be a meeting throughout the whole day. You guys are free to meet if you prefer. But in 2 weeks, maybe we could go over this. Unless
Yeah, we
Sarah,
can
you
skip
you
a
want? Yeah, you were
we can
planning
skip a
for a
week.
presentation.
Oh, sorry. I have one last question real quick. What are we gonna use for image creation? So other than the raw output of a code, are we gonna use all the same software? It's gonna be Google Slides or something. Shall we like standardize that as well?
What do you mean by yeah, Google Slides? We already have.
I thought
We
more like
already.
if people use Adobe Illustrator or something, like how do we make sure that we when we make sure that usually if you just use the output of Matplotlib, it just looks like Matplotlib. So usually people make the figures more appealing. And so the question is, shall we all use the same software?
Yeah. So I have generated in Sarah, do you have thoughts?
I think it doesn't matter which software people use as long as they save it in a vector compatible file format, right? Because you can't force people to pay subscription fees for Adobe Illustrator necessarily.
Yeah.
But I think,
Yeah, it's
people
very
who have
expensive.
it should definitely make use of it. Let's say it like that. But as long as the output is generic, it's fine.
I don't know if we want to do that, but Alex, my previous paper on denoising was entirely Matplotlib generated. All of the panels, even the little letters, there was no Adobe involved.
I can't imagine, I have to say, it hurts me.
But yeah, it worked.
Yeah, it's a matter of taste. I mean, like if you go on archive and everything looks like LaTeX, some people like it, some people don't. So, but I mean, because each of us is going to work on figure subpanels, right? And so we have to eventually create a coherent figure. So I'm just wondering,
That's right.
since we start working on that, if we want to find some free software that we could use for that. I like the idea of using vectorized graphics. I'm not sure if Matplotlib gives you vectorized graphics, but we could vectorize it.
I think it can save SVGs. Yeah.
Okay, great.
So one thing, I was actually surprised how good Claude Code is to actually create code which does a decent job at the figures looking. Yes, they are not Adobe Illustrator, but they are good enough. At least from my perspective, that was one of the things for which I used it the most from that perspective, because you're generally less afraid of errors there. Hey, the thing was not placed in the correct position. Yes, you can actually see it, right? So once you already know, so that could be a potential use for Claude Code as well. The other, in the past, I have been using Inkscape for whatever, 20, 30 years now. And SVGs work very well for that.
I would say I would add to that I think that I do use Claude Code for designing, I would say algorithms, like for coding reinforcement learning models, and I find that when using Claude Code for things that are much more experimental, it tends to hallucinate a lot more and does things that don't make sense unless you're very it does things that don't make sense in my experience when it comes to things that are much more experimental. I
Yeah.
imagine that has to do with the training data set used for Claude that didn't include things that, of course, are at the periphery of what's been explored in research.
Yeah, we definitely shouldn't just blindly trust AI generated code. I think we're on the same page. Yeah.
But do you feel like we could have a discussion in 2 to 3 weeks about generated content, I probably single panels. It doesn't need to be very polished, but just I feel like it would be helpful to just get closer to the data and then decide on what we want to show from the first attempt. Okay. And
so, Jerome, can you remind me again? So we have 2 NWB files for now. Will there be more by then?
That's right. Carter and I mean, Carter, are you here?
Yep. So I'm actively attempting we will almost certainly have NWBs for the Mesoscope available by the end of the week, and I'm pretty sure we'll have some available more for EFIS by the end of the week. So
Slap 2 might drag a little longer. Okay. Any other questions before we depart? Well, thanks everyone. It was really productive discussion. I learned already a lot. Have a good rest of your day.
Thank you.
You too. Thank you.